This time we're looking graphically at a situation where I'm giving you the derivative. And we want to think about what does the function look like at this point right here. And I'm going to give you the one hint that y of 0 is 0. So or g of 0, sorry, g of 0 is 0. So I know that that point's going to be on my graph. Well, from this, I know everything in here, from here to here, is negative, which means that the original graph would be decreasing along those values. So I know I'm going to be decreasing. Now, I'm decreasing here, but not as rapid of a rate as I'm decreasing right here. In fact, this is where my decreasing is going to be the steepest. So, and then here, I'm back up to here. So probably looking at something that would do something along the lines of that, just corresponding to the negative values here. Now, what's happening here? Well, if you look at the graph is decreasing, but again, we're not reading these as graph values, we're reading these as derivative values. So here, my green graph should be increasing. So now it's not increasing much right here, but over here it's increasing pretty steep. So it's going to do something like that. So we're steeply increasing till we get to here, then we start decreasing, and likewise when we get past this point right here, we start increasing again, and as we increase, the y values are getting steeper on the derivative, the y values are getting higher on the derivative, so the original function should be steeper. So it's going to take on the shape of something along the lines of a cubic graph. So the blue says positive, so we're increasing. The blue here is negative, so we should start decreasing. And then the blue over here again is positive, so the green graph should be increasing likewise. So that's a little bit of a look at what we can do as far as the graphing is concerned. Working backwards, now all of a sudden, let's say that this graph right here is the graph of my original function, and I need my red graph to be the graph of my derivative. Well, let's make it black. Our black graph should be the graph of the derivative. Well, here we're decreasing and we're getting close to 0. And likewise from here on out we're increasing. So the graph of the derivative, g prime of x, should look something along the lines of that. So that's a little bit of a look into the context of differentiability. From that worksheet packet, on the page that is page 122, questions 1 and 2 are matching questions, and then 3 through 7 are just straight up derivative problems. So let's just go with doing questions 1 through 7 there.